Now we're looking at irrational roots, and actually you tried it's an imaginary, but anyway, of and coefficients of a polynomial. So what this one is supposing is, all right, you have one rational zero of a function, which is c, and a second irrational zero, a plus square root b, are all the coefficients of p rational. So the factor, the way you can find that is just multiplying back together. So if you know a zero, c, the factor it came from is x minus c. If you know a zero, a plus root b, then x minus a plus root b is the factor. When I multiply them together, what you end up with is that nonsense. So no, the function p has two irrational coefficients. So basically what that means is it doesn't work. When you have only one irrational root. If you noticed the example that we just did, the imaginary roots that we got came in pairs, right? Irrational roots are going to come in pairs as well. So that's why you can't just have one irrational root. It's going to come in a pair. When you consider like a situation where there's only one, it gets messed up. All right. So that's what you're really taking away from this. Second part of the example supposes that you have two irrational zeros, and it's a conjugate pair. Remember, conjugates are when you have, in this case, rational and irrational numbers. They're the same. The only thing that's different is one's plus, one's minus, right? So if you take those zeros, get the factors that they came from, it's x minus those numbers. When you multiply it all together, you end up with is rational coefficients, meaning it worked. So that's what we're trying to get at here, is that these irrational numbers, when one's a zero, its conjugate is also a zero. So let's take a look at this example here. So it's really the same idea, just with an imaginary conjugate pair. So make them factors, make the factors that they came from, multiply them together, and then see what you end up with. So pause it and then come back and check. So when you multiply these together, I did x minus each of the conjugate, the zero conjugate pair. Multiply them all together. Look how I kind of separated the terms. All the imaginary terms canceled out. What we're left with is x squared minus 2ax plus a squared plus b squared. All that's real, right? There's no imaginary numbers left. So when you multiply, or it basically what we're getting at is, again, imaginary numbers work just like irrational, in the sense that if one is a root, the other, the conjugate is also a root. If you didn't, we would have ended up with some imaginary coefficients, which would have basically meant it doesn't work. All right, so let's take a look now at example 5.